My name is Ronald Bradford, and today I will be presenting about Amazon Web Services RDS Aurora capabilities. If you would like to follow along, my slides can be found at the following link or QR code. In this presentation, I will describe what Aurora is, what are the product features and capabilities of Aurora. We'll talk about why you may want to consider using Aurora, and I will present each of the high availability options that Aurora provides. To show Aurora in action, I will also be providing an example of how to perform an upgrade and failover of a highly available 2-instance Aurora cluster. I'll also provide some technical details as well as some additional summarizing of many features that Aurora provides. As a quick background about myself, I've been working in the relational database field now for over 3 decades, and I've been using MySQL since MySQL 3.22 in 1999, over 20 years now. I've presented at many Percona live events, and my speaking engagements have included conferences in 22 different countries. I'm currently the lead architect at Lifion, the next generation HCM system by ADP. Aurora is a MySQL and PostgreSQL compatible database specifically built for the cloud, running in Amazon's Web Services, the relational database service, that also provides popular open source and commercial relational database products. Some of the specific features and capabilities of Aurora is that it's a managed service offered by AWS. Aurora has been specifically designed around the architecture of an always-on cloud computing service. As I mentioned, Aurora provides both MySQL and PostgreSQL wire compatibility covering multiple versions. For MySQL, versions 5.6 and 5.7, and for Postgres, versions 9, 10, 11, and 12. For the purposes of this presentation, I will be speaking about MySQL specifically. However, most of these presentation points also apply to PostgreSQL. In MySQL terms, Aurora is a type of transactional storage engine. The cloud-native architecture splits the compute and storage requirements for highly available and scalability, as well as a log-based architecture that offers many advantages in improved recovery time, read replicas that do not suffer the impact of IO SQL thread implementation or replication. Aurora offers a single writer instance and up to 15 read replicas. Aurora does also support multi-master capabilities. The separate storage capabilities of Aurora provides a highly available and redundant 6 copies of data across 3 availability zones for your cluster. This approach to storage offers a number of built-in features. It offers better backup and recovery capabilities via snapshots and a reduced time for any type of crash recovery. One nice feature is also the ability to have fast DDL, not requiring a complex strategy or additional tooling to modify the schema for an always-on 24/7 application. A number of different capabilities are available to import and export data into Aurora, and also supporting copying clusters around, either duplicating or supporting additional high availability configurations, which I'm going to be talking about. Some Aurora-specific features include backtrack, the ability to rewind your database to a point in time and then move forward and back again. Another capability for upgrades is zero downtime patching that offers the capability of holding running connections to maintain application connectivity during the upgrade process. I'm not going to be talking specifically about these points in this presentation. In Aurora, everything is defined as a cluster. A cluster is one copy of the data, the storage, and one or more instances that are the compute for the supporting your application. 2 copies of data is available in 3 different availability zones using a quorum of 4 acknowledgements to ensure redundancy. A cluster is defined with at least 2 Route 53 endpoints, a writer endpoint that points to the writer instance, and a reader endpoint that load balances across the read replicas, or if there is no read replica, points back to the single writer instance. There is also the capability to create custom endpoints to include specific instances. For example, if you want to read from the writer and read replicas. Another feature is the on-demand scalability capabilities of read replicas using auto-scaling groups. This diagram shows an Aurora cluster within a VPC within a single AWS region. The underlying cluster storage volume is considered and presented as a single device. There is no visibility within this. The minimal or Aurora installation is a single cluster containing a single instance, and you can control which availability zone that instance is placed in. The cluster has its redundant storage and 2 Route 53 endpoints. The underlying instance also has its own specific endpoint that can be very useful in monitoring the cluster and instances separately during operations, such as an upsizing and failover that I'm going to demonstrate in this presentation. It is very easy to add a new instance to an existing cluster. The instance class does not have to match the existing instance. However, it is highly desirable if this is a candidate for failover. You can also define the availability zone for each instance. Several capabilities of a traditional MySQL replica are not available in Aurora cluster. You cannot, for example, mix MySQL versions or change encryption or have different table structures or data or privileges per instance. Technically, you can create an Aurora cluster with no instances. This simply makes your data inaccessible. Adding an instance provides the read and write access. The most typical of highly available configurations is an Aurora cluster that has multiple instances, one assigned as a writer and one or more as read replicas. You can choose your availability zone for your instances. Ensuring you have a highly available second instance should always be in a different availability zone. You can have multiple instances in the same availability zone. You can also configure the priority of promotion of your read replicas so that any automatic failover situation can be more finely controlled. You can see in our single instance cluster and add one or more instances to support reads. Reads are automatically load balanced via the reader endpoint. You can choose to create a custom endpoint to specify specific instances. I've not spent any time specifically with Aurora instances to evaluate the latency between your application and one or more availability zones. My work in RDS Proxy, a product I will not be discussing in this presentation, offers an additional high availability layer across 2 availability zones. My work here has shown that there is a small but measurable difference between the availability zone communication and cross-availability zone communication. While I'll not be covering multi-master Aurora capabilities in any detail in this presentation, this is a capacity you can use. However, in evaluating, I've found that some of the limitations would not support existing applications. You can achieve a multi-master write capability within Aurora Global Clusters that I will be discussing. The cluster is one or more instances. The storage layer is considered as one device. There's no need to have MySQL binary log replication between the instances. It is disabled by default in the cluster parameter group. You can enable MySQL binary log replication. My blog provides an example for the syntax for enabling how you can use it for various capabilities, such as extending your Aurora cluster to replicate to an existing RDS instance or an EC2-based MySQL instance, for example. You can use binary logs for analysis purposes of the write operations. In the current versions of Aurora MySQL 5.6 and 5.7, you can enable GTIDs. This capability is not available in the current RDS version 8.0 and will not be available in future Aurora versions. The MySQL binary log can be used for other purposes. This is necessary to enable change data capture for Amazon's data migration services, or DMS, where you can define a source such as a MySQL instance, an RDS instance, or Aurora cluster, and you can then apply the change data capture to multiple different targets. I previously used this to communicate with a different MySQL instance, emulating replication, or to a Redshift data warehouse, or even to a Kinesis stream that is then applied to a Snowflake data lake. You can use MySQL's binary log replication to have multiple Aurora clusters within a single region. We've seen this used for various purposes. You can have a blue-green deployment or a no downtime approach for major upgrades, or you can use this for standalone benchmarking capabilities. Enabling the MySQL binary log has the same characteristics as traditional MySQL. There's an increase in disk I/O in both the writer and readers, a longer transaction time to ensure ACID compliance, and you can see replication lag under load. We can start with one Aurora cluster and with a snapshot, launch a new Aurora cluster. You can then configure MySQL native replication, much as you do traditionally to communicate between the two clusters. This is an example of showing some of the differences of a managed service. All of the MySQL commands you are familiar with may not be available. AWS does not provide super privileges, and with this comes a number of RDS procedures to support different types of commands that you would otherwise require super privilege. As shown here, you can create a replication user as you would normally do. You can look at master status or slave status as you would normally do. However, for change master, you need to use a specific procedure. Some of these procedures can perform a lot more validation. A recent example was the need to progress the binary log to the next file. The procedure that performs this also validates its execution and starts the replication stream and processes and reports on the outcome. When you create a snapshot, you will get an instance event that will detail the binary log file and position. You can also retrieve this information from the cluster's error log. In this example, you can see the JSON output showing the position of the binary log. A different configuration for multiple Aurora clusters is multi-region. As with in-region, enabling the binary log is required. However, the setup is significantly easier. You only need to specify the source cluster ARN, Amazon's resource name, and all setup and management is done automatically, in theory. I recently had a bogus binary log event error that was corrected with the procedure that I just mentioned about the RDS. There are different advantages of having your data in a second region. For example, between a US region and an APAC region, local applications can benefit from lower latency. You have a warm DR failover strategy in place. However, a DR failback is additional work to implement. A big difference in multi-region setup, whether for Aurora or other AWS services, is that the monthly Amazon bill will now include a new line item for cross-region transfers. My only advice is to be mindful of this. Cost optimization is one of the pillars of the AWS well-architected framework. While inter-region across availability zone replication is free, intra-region replication is not. This visual representation is much the same. However, you will see you have a separate region, VPC, and different availability zones for your cluster. The final high availability configuration, and something that I'm presently implementing, is the use of Aurora Global Cluster. While Aurora offers a single region highly available and storage redundant solution, a global cluster offers this in multiple AWS regions around the world. In an upcoming blog post, I will be providing details of how to set up, review, and test an Aurora Global Cluster across 3 different geographical locations. The Global Cluster solution uses the underlying Aurora storage for data replication. Therefore, binary logging is not required. This addresses the traditional replication lag issue. While Aurora storage can also have lag, it also has the capability to manage incoming writes in order to minimize that lag. This HA solution is described as having a 0 recovery point objective. The architecture can block writes before any global failover, and all clusters will reconnect to the new master and become members, offering a truly DR, failover, and failback data store capability. It is important that applications will need to use the available Route 53 endpoints that cross these region boundaries, and so it's not as simple for the application just to fail over the database. With a global cluster, you get local latency capability for regionally located applications. You can also configure the read-only cluster in the region to accept writes. These writes are not applied, but as the configuration option suggests, they forward to the active cluster, apply, and then the cluster storage replication applies this to the local cluster that accepts the write. and accepted the original write. Visually, we have a cluster in a single region. We can then create a global cluster and use the first cluster as the source of this global cluster. This is a quick operation. However, if you wish to test this out, T3 instances are not supported for global clusters. You need to use R5 or R6G instance sizes. You can then create a new cluster in a new region referencing the global cluster, and all setup and data synchronization is handled internally. You will see quite a delay when the cluster is in a creating status while the data is being copied. As with a normal cluster, you can technically have no instances. However, you will require an instance to be able to access the data within any given region. And optionally, you can configure write forwarding to enable an easier representation to the application for data management of reads and writes. What is the most common operation of a running cluster? There are a few. Minor updates need to be applied. You can let AWS apply these automatically within a weekly defined maintenance window. However, you cannot control exactly when this happens. And so reading the notifications and performing proactively is important. At this time, for example, our Aurora 9 PostgreSQL clusters must be upgraded to a future version. This type of major upgrade, you would wish to control the execution and validation of. Scaling up and down is, and adding and removing clusters is another operation. However, this is a simple set and forget command. Everything else is managed by AWS. Scaling instance sizes is a little bit more complicated. And to provide an example in this presentation, I will demonstrate the steps of the operation, some underlying monitoring you should perform, and the outcomes. While you cannot have two different versions in an Aurora cluster, you can have different instance sizes. Upsizing is a multi-step process of starting with the reader. When you come to upsize the writer, you can preemptively fail over or let Aurora manage that for you. To the application, the Route 53 endpoint does not change. Existing connections are affected, as well as new connections for a short time. Your application should handle reconnection capabilities. Under the covers, this delay seems to be DNS resolution related. In a later table, I will show there's a loss of connectivity for 20 seconds until DNS connectivity becomes reavailable. However, the Aurora instance at that time has been up for 19 seconds. This example shows the AWS CLI commands to describe and modify an instance. You then need to monitor or wait until the instance status is back to available. The instance will go through several states, and I have a subsequent slide to show these. You can then verify the members of the cluster, who is the writer, perform a failover, and verify that the writer has moved to the new instance. In order to monitor what's going on, I've provided a few examples here, polling the instance status. If you do this with a granularity of less than 5 seconds, you can run into and hit AWS rate limits. You can poll your cluster endpoints and the individual instance endpoints to determine MySQL connectivity. In this table, I show an indication of the amount of time to perform a full upsize of each instance in this 2-instance cluster. It was interesting, as I was documenting these numbers for this presentation, one upsize placed the instance into a storage optimization state. I had not seen this before, and I had to go searching to see that this was a valid state. This added in the example an additional 12 minutes of time. I do not know exactly what it's doing under the covers. The instance does go through several different states around the true blackout time of connectivity. Visualizing the connections, here is a graph of the reader and writer connections. You can see the draining of all connections as the reader becomes unavailable and all traffic moves to the writer connection, and then gradually returns to the read replica as it becomes available. You can then see the failover where all application connections move to the new writer instance. I've rushed through just a few of the Aurora capabilities, focusing just on high availability options in this presentation. Each of these options has its merits in availability and cost depending on your needs. There is a long list of additional capabilities that can span many different presentations. This is just a list of some of those key features and links. Some of those include IAM authentication, Aurora's implementation of query cache, parallel querying, DMS, as I mentioned earlier, database activity streams, which is an implementation of a change data capture process, specific tuning, we've discussed RDS proxy that I mentioned, and the capability of auto-scaling read replicas. A few capabilities that I do want to mention. One is Aurora Serverless. As the name indicates, this is an on-demand service that is marketed as a cost-effective solution. Presently, version 2 is in beta. However, read the fine print. It does state do not use in a production workload and that all instances will be terminated at the end of the beta. In my evaluation of serverless, it takes a long time to wake up after you've reached the configurable cooling down period, which you can define between 5 minutes and 1 day from the last access. When I say long, I've experienced greater than 60 seconds for a response of an SQL statement. So configuring at 5 minutes, I consider to be too short. However, for a low use testing environment, having a 60-minute warm down time and between office hours of say 9 a.m. and 6 p.m. Monday to Friday, you have a scheduled cron job every 30 minutes to ping the cluster, you are effectively, when not used, saving the cost of computing resources for up to 2/3 of 160 hours per week. I'm still evaluating the capabilities and use cases here for Aurora Serverless. One wish list to-do item that I have is to take the built-in failure simulation operations and perform some chaos testing with Aurora. I have listed here on the slide the SQL commands that are available. However, other than just looking at the first command, looking at volume status, I've yet to emulate a system failure, disk failure, or disk congestion situations. If you are a true nerd theorist, you can take a look at a very detailed 4-part blog series on understanding how AWS came up to the quorum approach in Aurora. In conclusion, there is a lot to cover in a short time. I encourage you to take a look at some of my upcoming posts where I'll be providing some more examples that are used in the creation of this presentation. Aurora is a managed service. This comes with a distinct advantage for how you resource your operations team. It does come at a cost, and there are some limitations to operations or tooling that you may be used to. But you gain a lot of built-in features with one single service. Over my many decades, I could talk about experiences with MySQL instances handling 500 read replicas and complicated scaling approaches, complex 2-way or 3-way multi-master replication, DRBD, disk synchronization, various semi-sync and full sync solutions ranging from Galera to MySQL cluster. You have tools such as Proxy SQL, Percona online schema change, Ghost, Heartbeats, and so much more. I've also survived several AWS failures, from individual disks on critical systems to all-out EBS failure in US East 1, to entire availability zone outages and even an entire region outage. A managed solution can help in these situations. As I say, it's best to be prepared. Know your RTO and your RPO. Preparing for chaos is better than having to react to it. My blog has links to these slides and additional code examples and references around Aurora, including more technical details and the difference architects and administrators will see, such as MySQL, variables, status, information schema, and more. I would like to thank you for your time today attending this online presentation, and for those who will be watching this later streaming. A big thanks to Percona, who've put on this event and previous conference events physically in various different countries and now virtually online. Be sure to check out all the presentations this year, hundreds of presentations from over 150 different speakers. Thank you.